Morning. Today, we're going to spend some time working on this little guy. This is a Joker amp. It is a 1-drive-in-4. And this is the second example of this gentleman's work we've ever had come through the shop. I believe this to be relatively unmolested and truly does speak to the quality and the kind of craftsmanship that PEEKABOO produces. This is a PEEKABOO amplifier. It's made from primarily recycled components. I got to be very careful here. Now let me explain to you guys why. What I choose to say and exactly how I choose to say it. This gentleman is no fan of this channel or any of you that support this channel. He is pre-Facebook, there used to be this thing called forums, and there's the forum thing is still a legit deal. It's still going on. I haven't really bothered to check in on the status of some of the radio forums that grew to their monster manual hype before Facebook came along. But the guy that built this amplifier used to run a forum called Mall Droppers. Now I'm sure Mall Droppers is still an active site, and I'm sure he won't let go of it until the unicorns die. He wasn't the guy that started it, if I understand everything correctly, because I don't really care that much, but I kind of passively followed along. He ended up buying it, so therefore he was the owner of Mall Droppers, and it, you know, usually what happens when somebody gets in charge of a large forum, instead of supporting everybody universally, they end up just kind of turning it into a self-loathing thing. But the Mall Dropper forum is kind of interesting. It's very, very interesting when you go and you scan over it from today's standpoint. But the guy that owns that forum built this. And like I said, he's not a fan. And according to him, the only way to do anything is his way. Ever. So now we've all come to know and love the 1x4 form of amplification. It's a low drive system, and in this kind of deal you can do a high-low environment where you can switch out the driver, kind of like the old sweep 2 boxes, or you can put an attenuator in line, like, if I'm not mistaken, this one utilizes an attenuator. That's all it does. It does have a preamp. It is sideband and sideband biased, and it's got a primary on and off switch. Woo, look at that. It does have full regulated bias in it over here. It's got a couple drivers and some voltage regs, and that's us turning the amp on and off, and it goes through each one of those cycles when it keys. This amplifier uses a lot of very interesting tuning. It utilizes capacitance decoupling and capacitance coupling in multiple different spots. None of the transformers have 100% reference to ground. They all go in or out or through some kind of isolation capacitor on their primary side, at least on the output. The inputs are 100% reference to ground. Like I said, it does have full bias on it. Just sitting here passively looking at it, these are our resistive load diodes. There is not one on the input, which I'm sure this is just piggybacked onto one of these. It's just a lot of different stuff going on. As we can see very clearly, let's look down the line of things. This is the transistors. And instead of being in the middle of the metal mass, our transistors are hanging out way out here on the front edge. So that means we only get heat absorption in this front bit of the heat sink, which is kind of interesting. And it's just There's a lot of different ways to go about doing things. Now, we've got to get in the Wayback Machine. Okay, we've got to go and get in our little time machine and pretend like we're the Jetsons. And we're going to fly back to the 90s and the early 2000s for a homebrew box. This isn't all that bad a construction. It's not. It's really not. There's some stuff in here that's actually ahead of itself. Way ahead of itself. Spin this around, we'll take a look at such set examples. Sorry, my phone's going crazy. I had to make sure no one was dying. Phone's sitting over going bzz, 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 bzz. The whole key circuit / preamp circuit actually being mounted down on a board. The fact that we want to lift up our wires and not have them laying down on a heat-soaked surface. I mean, there's a lot of positive things inside this amp. But there are a couple negatives. And this amp does have a few little problems, which today we're going to work on fixing. And we're going to make it better. And in no way are we taking a finger and pointing it right at old PEEKABOO. None. We're just saying, look, our job is to fix the amplifier. And our job is to sell such that amplifier. Let me explain to you why. The gentleman that owns this amplifier has lost a lot of health issues, or a lot of battles with health, and he is coming to the end of things with his life. And he has asked me to repair and return to the radio world this equipment, and to take the money and send it on to his family. We have sold his other amplifier and worked through all of those problems, and today we're going to repair this one, which is a capacitance change, I do feel, and we're going to talk about what's going on with this here in a minute. This thing has got yet a whole nother life ahead of it with some new user. It's got a bunch of good components, and the guy that built it put a lot of tender loving care into it. I can tell that the final section over here has been apart once or twice. We're going to go find out where the imbalance is in this portion of the amplifier. This is stable, this is stable, this is not. There's something going on here. We're going to work through that, but first I want to run it and show you what we have for demonstrated output power. Our job is to fix the amplifier. It is not to sit here and talk smack. The last and first and only example pre this box of this gentleman's craftsmanship, I'm proud to say that this one has 50 ohm coax in it. Actual 50 ohm, commercially made, certified coax. The other example, the first and the only one that I had until this example has decided to come here, had homemade, like 16 gauge Teflon PTFE wire inside of a shield soldered to the board. Just pointing that out. I'm glad that this one does not have that situation going on. I mean, there's a lot of really cool stuff in here. And you know, we just take ego out of the equation for a minute, and we just look at stuff as a craftsman. We're going to go in here and we're going to admire just the craftsmanship and some of the stuff that is done inside this box. Let's go over here and look at the attenuator circuit that's going on here. It's a little different. The output combining. So the RF comes out of the transformer and it passes through a capacitor, through a second capacitor, and then goes to the combiner circuit. So we have a pre-balance and then an actual final balance resistor down in here. But we don't have the same thing going on here. This is our input, this is our output, It's got an inductor coil for compensation. We've got strapped Toshiba 2879s. It's just interesting. It's just very interesting to me. Let's do the old Sharp A test. Let me grab a Sharp A here real quick. Tip 61, tip 61, tip 61, tip 61, tip 61, 61, 61, 61, 61, 61, 61, 61. Oh, type 43. I found type 43. Also type 43 and type 61. We do those little kind of tests to verify that all the transformers have the exact same material make. With this thing throwing up the handy dandy, hey, I've been apart many times, that's when we're going to go and we're going to look at all the materials that make up the transformer. Because who's to say, back when dinosaurs roamed the earth, maybe this guy just by chance and didn't notice. I'm not putting the blame on anybody now, because everybody's so sensitive. Maybe a couple of these pieces, maybe, just maybe, one got up inside the woodshed that's not supposed to be there, and there might be 61 and 43 mixed in someplace, but no, that's not the case. So, just have to check. Gotta check. Okay, let's hook this thing up. Let's get the spectrum analyzer running. Let's take a quick look at it. Okay, let's establish our baselines of measurement. Oh man, it's Monday. My phone's gonna go crazy today, I just know it. Okay. 1,000 in peak, 1,000 average, 5 slot, 5 watt slug in reverse. We're down on 12 volts this morning. We're gonna use the very inevitable or venerable bench RCI 2950. And we're gonna use the 5 watt slug between the 2950 and the stuff down here on the bench as representing our input into this thing in both forms of operation, pass-through and input. Let's go over here. Let's take a look at what we got going on here. We're starting at 0 megahertz. We're stopping at 200 megahertz. We got 31 dBs of attenuator. Reference line is negative 6.5 dBm down. The total, we're looking at, oh shoot, what are we? Noise floor is down there around 51 or so. Let's go ahead, we'll shut the amplifier off. First, we're going to show you input. Hello, 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2. Okay, that's our principal. It's our input working frequency. Let's go over here now. Hello, 1 2 1 2 1 2 1 2 1 2 1 2. That's our input power. That is how much, and that is where it is. So it shows us exactly where in the frequency band things are. And this shows us how much. Here, that shows us how much is going through. So now let's come up here and let's look at our input tune, or pass-through tune. I mean, hello, 1 2 1 2 1 2 1 2, which is not T-bag. Okay. Now remember, we're on 12 volts. We're going to run it on low at first. Hello, 1 2, making roughly 400 watts of peak. Hello, about 180 bird. Let's go to high. Hello, audio. We're making 500 watts peak. Hello, and 200 bird. And that, boys and girls, is on 12 volts. So let me get down here. And we'll turn this up to a little bit more standard operating voltage. And we'll see what we get for performance now. Turn the amp off, put the amp back in low. Okay, now we're up around our 14 volts, our standard automotive operating voltage. Hello, 1 2 1 2. Here's our 20 watts. Hello, 1 2 1 2 1 2 1 2. Pass through tune. Hello, 1 2 1 2 1 2. Starting to creep up there a little bit. Okay, Let's turn the amplifier on. We are down and low. Hello, 1, 2. We have seen a significant power increase. Imagine that. Hello, audio 1, 2, 1, 2. Let's go look at our input. Hello. I'm afraid to say anything because somebody out there will twist my comment on anything into it being negative. I am just simply representing the sandwich to which I have been served. It's my job to fix it from here, right? So let's put the amplifier in high. Hello. Wow. Wow. Okay. Back to low. Hello. Back to high. Hello. Oh, it's 6:30 in the morning. The phone's already starting to ring. So what we have seen. Hello. We're not seeing that much change between low and high. We're putting 20 watts in it. Let's go look at our input. Reflect. Let's lock this down because I can't sit here and hold on to the camera. We're going to start out on low and switch to high. Hello. It's significantly less on high. Now, there's not a self-respecting radio operator out there that isn't going to run it on high all the time, so it's probably not even an issue, but we're going to look at that. Here's the issue I take with it. And I am in no way, once again, I hate the fact that I got to act like this. I really do. I think it's stupid, me personally, that us as repair centers have to defend ourselves and continuously remind people. We can't just say it once. We have to say it 15 times. Otherwise, somebody out there is going to get on their little keyboard and go, oh my God, I can't believe what BBI said about so-and-so. I'm not doing that. What I am talking about here is simply what the piece of equipment's doing. We're going to make it better. So stop it. Grow up. Let your balls drop. It's good. Junior high's over. Like 40 years ago for most of you guys. Okay, so that's our principle. That's our input. Hello, 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 hello. Okay. This is what the amplifier produces on low with an unmodulated carrier. We see a little bit of dirt there. Some of this dirt, like this little spike, you can see here in the middle, we don't worry too much about it, but this one here, we do kind of worry about that. So let's modulate this a little bit. Hello, 1, 2. Now we do see that most of our signal is actually on frequency. Right here. That second spike is pretty significant. So let's go ahead, we'll run this up on high now. Low, high, low, high, low, high. Hello, 1, 2. Now we will from time to time get a little bit of modulated dirt, like what we're seeing going on here. When we modulate, it's just part of it, okay? It's not ideally perfect, but we don't live in an ideally perfect world. So, even the owner of this equipment, the note that he sent in with it, states that the one section in the 4-pill section of the amplifier gets significantly hotter than the other section, which tells me he's had this fail before. He also goes on to tell me in the notes that that section has been apart because it has broken on him 3 or 4 times. So Let's get the old FLIR out and let's see if we can get some digital visual proof. That's the downside. You know, I miss my old little FLIR, the entry model one. You kick that thing on and it was booted, ready to go. This thing, man, they pretend like it's a 1995 Windows operating system or like Mac 1 or whatever the hell it is for Apple IS or OS, pardon me. Okay. We're looking at just strictly heat. And we can clearly see these flybacks are way hotter. This transformer is way hotter. But look at the heat coming out of this attenuator pack over here. Doing its job. This output transformer is fully saturated, making a ton of heat. We got to go find out where the imbalance is. There's no heating in the combiner in the back, which is kind of cool. But for around 14.5 to 15 volts, we're several hundred watts low. And over here we're spread way out. So I wonder if we go in here and we make just a couple little tweaks, what we can get to be cleaned up. I'm not a big fan of this. I call this double tuning. So capacitance, inductor, capacitance, splitter. To me, I want to see only capacitance here and then splitter, or have just capacitance here but not here. This bothers me quite a bit. I mean, we're passing 500 some watts through each one of these. I'm not a big fan of that, but we're going to check a couple things here and let's see if we can get this thing to pick up its output just a little bit more. And let's see if we can get it to settle down on the spectrum analyzer. Hello. Wow. That is screaming hot. This is screaming. He's got an attenuator input, output, attenuator on the low, medium, and high, or low, high side. One of these disc capacitors is getting stupid hot. This thing's getting stupid hot. Each one of these is getting really hot. These little tiny. Ugh. Hello. I'm gonna throw it in there so you guys can see it. Anywho, let's go play, gentlemen. The second of two examples of this gentleman's craftsmanship to ever come into my shop, ever. Whew. Yay. I put the lid back on it because I wanted to run it to pull the heat out of the circuit, because I want to go back and do a couple heating tests with this thing off camera. And I wanted to point out there are a couple things here that I actually kind of admire. Big heavy duty grommet, big thick metal for the cabinet. He probably broke most of these by hand, but I admire the quality of the measurements here. It's actually square break. It really worked well. I enjoy and respect the big remote plug. I mean, that's a heavy duty military plug. That's, I mean, come on. And I'm sure the remote does everything that's on the front of this amp. High, low, everything. It does all of that. I'm sure of it. I don't have it. The guy that owns this amplifier's got it, but the other thing I admire is this. In this time, most people would just bend a piece of aluminum across the back and they'd punch like 5 little holes across the back and be like, that's it. That's all it needs. There is no air restriction for the most part from the cabinetry design going on here. It is a straight, let the air flow. This is not cheap, extruded heatsink. This heatsink is ribbed for her pleasure, and his as well. Now, each one of these fins has got, it's not smooth, it's It's got little stepped edges to it to increase its surface area. I think the heat sink in here, and it's super tall. This whole thing is heat sink height, where a normal heat sink bed is only about that big. I'm one of those people that can look at other people's craftsmanship and admire what they've done. I'm just that kind of guy. I don't feel it's necessary to bag on everybody else. Actually, I don't ever put anybody down. That's not my job. Like I said, my job is here to just repair it. But I was noticing the quality of this. Good, high quality wire, not cheap. But this hunky heatsink, I wish that he would have, when he manufactured this, would have put the transistors a little bit more in the center of the metal mass. But that wouldn't have worked real estate wise for layout for the rest of these components in here. I mean, if he could have just slid the heatsink forward a little bit, or brought the transistors a little bit more to the center of metal mass, that would have been totally cool. But okay, let's go unfuck this thing. So we took this piece of Type 43 out and replaced it with a Type 40 or Type 61 on the input splitter. The reason we did that is because we wanted to eliminate all that the garbage. We'll call it that. All that spurious emission stuff. And it took it took about, well, you'll see. It took quite a bit of it out. Now, that secondary harmonic, that was a little bit tougher to kill. And that had to do with the tuning of the capacitors over here. Now, we're talking like a two or three puff window to get it completely suppressed. But we got almost 20 dBs of that signal eliminated. It's gone. We fixed the input tune to where it is now, instead of 5 watts pinned in the corner on high and low, it's like 3/4 of a watt maybe, all the way down to like 1/4 watt. So this is fixed. This is safe for somebody to use now. Not that it wasn't safe before, it's just a little bit better. Now, by us changing the output tune a little bit, we get a little bit more power out of it. We're on high. Turn the amplifier off. Same amount of power as what we had going in it before. We're getting about 925 watts out of it. 125 watt gain. Just by twiddling around with the tuning. This is the fun bit. Let's go look at the spectrum analyzer. Once again, radio. Now, if you can remember, that second harmonic was tremendous, and when I would go to modulate it, it would turn into the Sherwood Forest. The second harmonic is present, but it is a full 20-25 dBm down. Huge difference. Huge. Let's go over here and look at our input tune. It was pinning a 5 watt slug in the corner. On high and on low, the problem with the input tune was this here. Was this relay. As you'll clearly see, that is low, that is high, that is low, that is high. What happened is, as the RF comes in from this wire, goes down, then it's got to go through all of this extra inductor. Now he's utilized both sides of the relay, this leg and this leg. So there's this whole extra amount of inductance that was not accounted for on the input circuit. By adding one capacitor, it eliminated that high input, took it completely out of the box. Now by adjusting our output tune, playing around with these caps here and then changing, we added one here on the final section because there was no final capacitance. He was using coupled capacitance as the tuning mechanism. We had a little bit, it was 100 puff worth of capacitance to the output tune. That secondary harmonic around 50-60 megahertz dropped, and also the heating issue that we had going on with this section of the amplifier went completely away. I was like, okay, just gotta leave it alone. If it would decide to focus on the camera. See, everything's universally the same heat. Let's let this cool off and we'll give you a little bit better contrast picture on the FLIR. Okay, so amp is thoroughly cooled off now. Hello, 1, 2. Hello, 1, 2. Hello, 1, 2. Now the phenomenon that we were looking at was this transformer was getting really hot. These flybacks were getting really hot. And there was an imbalance that was taking place. And what it was one of these capacitors, one of these disc capacitors. It was like a, what was it, already pitched? It's like a 102 or a 103 capacitor that he was passing all the RF through. Had broke down. So I'm proud to say, hello, audio. I am proud to say I think we've got all the little bugs worked out of this guy. Hello. 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 Yeah. It's working way better than what it was. Way better than what it was. My phone's ringing. I'll be right back. Hello. About 880 or 980 watts, pretty steady. Well, gentlemen, this is for sale. This has got to go to a new home. This can't stay here. I don't want it. I don't need it for anything. The guy that owns this, he's not interested in keeping this for anything. He's actually done with radio, and I need to send the money to his family. Because he is, well, we're just going to say he's just not doing so hot. So, I think we're going to ask $850 for this plus the ride. It is 1 2879 driving 4 2879 Toshibas. It's got the 150 amp Anderson clip on it, and you hit it with a 35 watt radio, 40 watt radio. This thing will run forever for you. So, you all know the drill. First one to call or text gets it. And I don't care where it goes, but it cannot stay here. Gentlemen, I want to say thanks to every single one of you guys for tuning in. This is, like I said, the second piece of equipment that we've had in here from this gentleman. And it just puts a smile on my face. I'm glad we could get it fixed. And I appreciate every single one of you guys. And I'm on to the next one. I think the next one's a Tokyo high power, I do believe. I don't know. We'll have to wait and see what's inside this giant wooden crate that's over here. I thank you guys. I'll see you. Click, click.